Hello, and welcome to the Spec Shaman Podcast, the show that explores the world of building product manufacturers, architects, and engineers, sustainable design, and technology and trends. We engage in thought-provoking discussions with renowned experts, industry pioneers, and visionaries who are making a significant impact in the construction industry. Join us as we explore groundbreaking ideas, revolutionary concepts, and the latest advancements shaping the built environment. The Spec Shaman Podcast is hosted by Laura Elliott, the lead instructional designer at Ron Blank and Associates. Laura is a seasoned interviewer with a passion for uncovering the untold stories behind success. I hope you enjoyed this week's episode. Let's get started.
Hi, and welcome to the Spec Shaman Podcast. I'm your host, Laura Elliott. I'm joined today by John Dalton, Technical Service Manager for Fire Protection Products, and Rick Mihevc, Business Director for the Thermal and Acoustic Solutions with Saint Gobain. Welcome to you both.
Thanks for having us.
Nice to be here.
We're really excited to have you here today, and I want to get right into it. Could you tell me a bit of your origin stories and how you both met?
Yeah, Rick and I have been working for the same company for about the past 25 years in the same fire protection market segment. And so I really can't remember a time, and Rick has kind of come and gone, but I can't remember a time when I've been in this industry where I haven't been working with Rick in some capacity.
And I've been, as John said, for the last 30 years, part of the fire protection business, Applied Fireproofing.
I'm sure there's lots of great inside jokes between the two of you then, with such a long history.
Oh, we have a great time, believe me.
So I would like to get into some of the expertise that you have regarding fireproofing. Could you tell me a little bit about it and how it protects a building?
Sure. So fire protection, as we deal with it in any type, is something that insulates the steel. So it can be a product which is a cementitious product, which is mainly just sort of several raw materials, some of them proprietary, mixed with water, sprayed onto the steel. And in the event of a fire, they keep the steel cool enough so that it can allow the people in the building to get out, the firefighters to get in and to fight the fire, and to keep the building sort of strong and square so that smoke and flames do not pass through walls and other stuff like that. That's kind of the basics behind it, whether it be a board product or an intumescent or a sprayed cementitious product. They all kind of work off the same principle: keep the steel or the concrete cool and allow egress and ingress as needed.
Could you tell me a little bit about how cementitious fireproofing was developed?
Yeah, it sort of has morphed over the years. It's been around for about 100 years or so, probably a little bit longer. Since about 1918, the ASTM developed a standard that determined how to protect wood and steel buildings. And it has sort of developed and become more sophisticated over the past 120 odd years. Initially, most of these products have changed significantly over the last 25 or 30 years or so, but technology and the need behind it is relatively old or stable. We have been sort of at the forefront of the development of that, from non-asbestos fireproofing in the early 1970s to development of cementitious fireproofing as we know it now in the 1980s, and then various modifications and improvements over the past 30 years or so.
Laura, it's real interesting because John and I have been in the industry for so long. I came in the mid 80s working for a contractor, and John, shortly thereafter. But we were talking the other day about when we actually entering fire protection, and John went back through the archives and found our first fire test was in 1938. And so if we think back to 1938, that was quite a long time ago.
That's quite a legacy. That's a lot of development iterations, I bet.
It has been, and there's a lot of testing that goes in for any manufacturer that is in the applied fireproofing business. There are a lot of tests. Probably have over 100 UL designs, and it's also a barrier to entry for other manufacturers coming into it. The testing that is necessary is very expensive, and it takes a long time to complete.
What is a normal testing phase?
I think from a development of a new product to getting all of your approvals, you're probably talking somewhere about 5 years.
Mm-hmm.
And from the time you think of it to going through your various testing, as Rick mentioned, the cost of testing at the various testing agencies is prohibitive. Millions of dollars just to get a product, and you may end up with something that's terrible at the end of it. You really have to put a lot of time into it up front, do testing when you no guarantee of a result, and then sort of once you pull the trigger on it, you have to have your best day. So it is expensive and it takes a long time to get there.
It's probably why there are only 3 manufacturers in our segment. I look at the industry that I've been in for a long time, and there's been great strides in the world of intumescent fireproofing, the materials that look more like paint. And a lot of architects like for exposed finishes, but our category, cementitious fireproofing, in section 7800, there are really only 3 of us. And for the foreseeable future, there will only be 3 of us. And it's because of the cost of testing and the difficulty in bringing a new product to market.
Is the cost of testing one of the defining differences from other types of fireproof products? Or are there other factors that make it different?
No, we all go through the same testing and are held to the same standards fundamentally. It's just that there are so many different types of construction that have to be tested to have a complete portfolio, that there's really no way for a new manufacturer to economically enter the category. It's just, I really don't expect to see it.
And I think, just to add a small bit to that, Laura, there are various testing agencies that can run these tests. And everybody knows some of them, like UL. You look at the back of your phone, you'll see a little UL stamp there, and UL are very well known. You can go to many smaller testing agencies and do some of this testing for cheap, or less expensively. But you really want to go for the cachet names, the likes of UL or Intertech or ETL Semco, because they're the companies that everybody knows. You go to these smaller testing agencies, which are cheaper and can get you where you think you need to go in a shorter space of time and for less money. You'll end up paying for it after, because people want to see a recognized testing agency. You wouldn't buy a life safety thing for your car seat from some testing agency you never heard of.
Yeah, credibility really does matter, especially with something that involves life safety the way that it does. Speaking of life safety, how does your fireproofing protect occupants leaving a building and the first responders who arrive to put out a fire?
We generally say that for a fireproofing material to be effective, it has to stay in place. And so ultimately, when these types of materials are evaluated, their ability to stay in place for the duration of the code required fire duration is important. And so physical properties of materials come into play. It's been a bit ago now that the codes have changed and recognized that bigger structures, taller buildings should have higher performing fireproofing materials. And, I think, and we think that was a very prudent change to the building codes, because it does allow the firefighters to get in and the occupants to get out in the event of a fire.
Yeah. And some of those taller buildings will have sort of areas of refuge as to what exactly means getting out of the building. So if you're on the 60th story of a high rise, getting out might mean just getting to an area that is safe, like getting to a place of refuge. And everybody, even the layperson on the street, if you ask them what causes deaths of people in fires, they will tell you it's all about smoke. And smoke, generally speaking, moves around from the point of origin of the fire, because the smoke or the the fire stopping products have been compromised. And the only reason they're compromised is because the structural steel will bend, or people will leave a fire door open, and that allows the byproducts of the combustion to escape and move around the building. And once you get beyond a certain number of sprinklers, it's very difficult for the sprinkler system to work. Like only 1 or 2 sprinkler systems typically work. It's not like the movies where they all flash down. So if it, as I said, keeps the fire stopping and the smoke stopping products in place, allows them to work, it keeps the fire at the point of origin. And generally speaking, that's how it works. And, Rick had mentioned a little bit too about, people talk about fire resistance ratings for an hour or 2 hours, and typically that's what we're at. But we want that product to work 45, 50 years down the line. We want the product to be durable enough that it's not just about the 28 days when the inspector rocks around. It's about, 28 years later. Because nobody thinks about it. Like the euphemism in the fireproofing industry is for products that may not work in 28 years. Spray and pray. It's just you spray and you forget about it. You hope for the best.
Yeah. Let's do a little better than that. When you look at other fireproof products, how does cementitious fireproofing differ?
Fundamentally, when you talk about the categories of applied fireproofing, the vast majority of the segment in North America is cementitious fireproofing. There are two different technologies. One is a gypsum-based material, the other is a cement-based material. The gypsum-based materials are generally used more for concealed applications or exposed applications that aren't subjected to abuse. The cement-based materials, also cementitious materials, are more meant for areas that you would expect as a specifier or a designer to receive some type of damage. So a column exposed in a parking garage probably should have a little bit higher performing material than, say, a beam that's exposed in a retail space. Both applied materials would be exposed, but they're very different in their application. So the cementitious category, defined as cement or gypsum, is about 80% of the marketplace. Of applied fireproofing, intumescent has grown significantly as it's become more economical, and that really is the majority of the segment.
That's a great delineation. Thank you for explaining that. When we're looking at global carbon emissions and how much the built environment is a contributing issue for that area, it plays a critical role in LEED credits and focus. Can you discuss how fireproofing can help LEED projects reduce embodied carbon?
Laura, that's an interesting question, and one that, despite being in the business for 30 plus years, I really wouldn't have considered until last year. We were working on a project in Milwaukee, redevelopment of a building for a major Wisconsin-based insurance company, and they were removing their old fireproofing in an existing building and putting in new. They were refireproofing the building. And we had a contractor that called on a Friday afternoon, as contractors are prone to do, with technical questions, asking if I knew the GWP, the global warming potential of one of our gypsum-based cementitious fireproofings. And I, on a Friday afternoon, kind of laughed and said, of course you're calling me now and asking me, after 30 years in the business, a question that I don't know the answer to. But I went on to ask, well, why do you need to know this? Why are we bringing GWP into a conversation about applied fireproofing? And I guess I'll try to figure it out, but what's the situation? And it was interesting because it was something new, and we had a developer and an owner and a builder that are all named brands in the construction industry that were going to buy their applied fireproofing contract based on GWP, or embodied carbon, of the materials. And I, at the time, thought, well, I really don't know what this answer is, so I'll call John. And John told me.
I think you're up, John.
Yeah, John said, well, Rick, I'm on a boat and it's Friday afternoon. Actually, I was up in New Hampshire, but I knew it because this is something that I've been dealing with since about 2005, when LEED was just sort of becoming a thing, and I had sort of been said, here you go, and I want you to learn more about LEED and sustainability. And so I knew it, and we had been actually working with one of the developers of EPDs, who was really great about just sort of diving into it beyond the numbers. He said, look, this is just a pile of numbers and you can look at it, but if I were you as a big manufacturer, I would dive into this and see where you can make some energy savings on your own, even for your own bottom line. It's a really good thing to do. So I knew the number, and I was able to tell Rick within an hour or so what the GWP number of our product was, and he was able to compare it to the other fireproofing companies in the market. And lo and behold, as we may get to a bit later on, like we have a very good GWP story for lots of reasons, but that was sort of the backstory of why it became a thing for Rick. And from there, I suppose I think it's probably back to Rick to finish it out, but.
Yeah, Laura, it was funny because, here I am. I think I know everything about the industry, and I'm being challenged on a physical property of my materials as the director of the business that I don't know. So John coming back and saying, well, Rick, I think he was a little bit embarrassed that I didn't know, but that we were actually in a really good place, and that our product was so high performing in terms of GWP, which means it's low performing with low numbers. And it was great to be able to go back to our contracting base that was bidding the project and say, we have a good story to tell for your developer. The products that they would be using if they selected our company are actually as high achieving in terms of GWP as any manufacturer could hope for. There's a lot of reasons for that, and a lot of them that we were intelligently thought of through the years as the product development and manufacturing has grown. But a little bit of luck involved too, and I'm not embarrassed to say that.
So not necessarily an intention, but a great unintended consequence.
We have some great unintended consequences related to where we make materials.
But it's not just that. Like we make materials where we make them, but we've had prior management who were determined that the raw materials that we were going to use were going to show up or were going to be sourced within 150 miles of the plant or very close to the plant, just because they had experienced situations in the past with supply chain crunches and our oil embargoes and whatnot. And we were also fortunate enough to be able to, or we were fortunate enough that we had a company who believed in us and said, you will do better on GWP if you do this. And I mean, it wasn't an inexpensive undertaking, but we were happy that they did it, and we remain happy that they did it and that they continue to look forward in this space.
So what are those steps in helping lead projects reduce their embodied carbon? Is it choosing fireproofing over another product, or in changing the usage? What are the best ways to create a reduction in carbon?
I think it starts with actually having a goal in mind and being willing to ask manufacturers questions about that goal.
One of your earlier guests, Yukari, she had talked about that, about what are the next steps, or how do architects and specifiers reach out or find products with lower embodied carbon. I suppose the question is just asked. There's not many of us in this space, and you don't really have a choice when it comes to fire protection of your buildings. You really have to do it. The code mandates it. So that's, you're going to do it regardless. You can sort of play around a small with it and reduce it if you want, but you have to do it. So fireproofing is a necessary evil, I suppose, unless there's a fire, in which you really need it. But that's sort of you have to make a choice. You have to reach out to the manufacturers and ask them for EPDs, third-party verified EPDs if you can, and then take it a step further as architects, as specifiers, as GCs or building owners, and don't just look at it as a ticking the box exercise where, okay, I've got the EPD and I'm going to get a lead point. That is so like 2010. We've moved beyond that. We're looking at EPDs for the value that they bring, and not just the global warming potential, but all of the other transparency and sustainability attributes that a product may have. So if you've got a lot of recycled content, maybe it overcomes some lower GWP, or if your products don't have any red list materials, it may be better than a product if it has no EPD at all. We were fortunate enough that we've got all of those sort of boxes ticked, but not just that, like that we're looking for sustainability beyond LEED. LEED is just up to a point, whereas we want them to take it a step further and to work to reduce the embodied carbon of their buildings across all of the building materials.
Laura, John comes at this very much on the technical side and the sustainability side, and I'll admit I come as the business director, trying to understand how our materials help us serve the architectural community's goals in the most economical fashion possible. And so, we really saw on the project in Milwaukee, which is under construction now, that we were roughly 1 million pounds of product, 180,000 gallons of water would be used for the application. And when John was telling me the difference or explaining me the difference in the materials and why, it was kind of an eye-opening moment for me. But I still got to the point where when he was telling me and he was expressing things in pounds of CO2 equivalent, like, well, what does that difference actually mean? So what is that quantity actually? Are we talking about 100 pennies or $100? What's the scale?
Right.
And so it really was that eye-opening moment when on a mid-size high-rise with 1 million pounds of product that, we were roughly the equivalent of 200 acres of mature forest digesting that carbon difference for a full year. The number of gallons of gasoline that was the difference between us and our competitor on the project was staggering. And it really put it into perspective what the difference in embodied carbon ultimately was.
That must have been quite the revelation.
It
Really
was,
was.
really, it definitely was.
Yeah.
For me, as the business leader, it's like, well, this is a pretty big difference between two products that, generally speaking, are relatively
Similar.
equal
Yeah.
in specifications.
Right.
And this is a real differentiator for somebody for a firm, for an owner, for a developer that's actually looking for differentiation.
Well, and it's like you're the fastest horse, right? But we want all the horses to be fast. I applaud it. You're setting a standard, right? That's the goal, is that we want everybody to at least hit the bar, right? And to start really to make progress across the industries. I think it's a great win in the moment. I know these moments can rapidly change your perspective, right? Of like what you're doing and how you're doing it and why it matters. But you're also like the first. It's a good example for where we need to go, I think, as a whole.
One of the things that you mentioned how it's nice to be the first, but we have noticed that our competition has kind of somewhat followed suit. And
Right.
so as a bigger picture, like on the bigger picture, it has been somewhat fulfilling to see, okay, we know that they're following suit, maybe because it's a whole business thing, but maybe that at least they're coming down in their GWP. And that has been heartening, that the industry as an industry has taken steps to reduce their GWP. I know that our GWP has come down by about 50% in the past 10 years. And we account for about 2% of the GWP of a building, which is big enough.
Right.
If every industry was able to reduce by 50%,
gosh,
we'd be in great shape.
Yeah.
John and I talk about this as we're talking about, the path forward that our industry that we've been in for basically our whole lives is taking, and it feels great to work for a company like the one that we do that really does mean everything they say about sustainability, and to hear it coming into the architectural community. But our architects have told us very definitively that most of this is in an owner and developer's hands. That really the owner and the development community has to be the one that makes the effort and wants to build that way. Architects can guide them, but it's up to the owners to really have that commitment. I had an interesting. I'm in Chicago, and Perkins and Will has always been my client, and it's kind of one that I've held on to even as I've changed roles. Talking with Mark Walsh, the global technical director for Perkins and Will, and he said, Rick, Perkins and Will is absolutely behind you in this conversation and the steps forward that you've made. But we also need owners to be willing to support that.
Right.
And to some great extent, Mark said, you hire a firm like Perkins and Will, you kind of expect it because that's what they are. That's at their core, just like it's at our core.
Yeah. No, those are great points. And I think that it's a great thing to learn. I think one of the goals of this podcast, right, is to really be a true connection point for the conversations that are happening across the industry. And with the Yukari episode, we were discussing that, like, there's all these shifts that are happening kind of prismatically, right? Like, design professionals are moving into these spaces more and more and really focusing on sustainability. And that trajectory has been going on for decades, right? And manufacturers, there's some pretty serious risk involved in some fields regarding sustainability, because it's an evolving target, and you could create something that would be declared sustainable 1 year, and then 2 years later could have like a health product declaration issue or something like that. So, it's a challenging set of progress that you're trying to enact. And you're bringing up a really great point, because the owners, right, what you're saying, they really do have an integral role in this conversation, and there's not really a lot made for them. Like there's not really a lot of content made for them to really help them understand what everyone else in this entire built environment community is trying to accomplish here. We all have different points of pressure that we're getting. But that might be a future episode.
I think that we remember the successes pretty clearly, and we had another one outside of Chicago again with IDI Logistics. They have some pretty aggressive goals in being the leader in sustainable distribution construction, and we had a project. It was roughly this time last year. The materials in the industry, we can kind of be a toss-up as to which product actually gets selected. We noticed that IDI had some pretty stated goals about what sustainability meant to them. And so we gave them a call. We were able to discuss sustainability and embodied carbon to a real great extent with them. They were willing listeners. And best yet, they owned the pocketbook. That was their project. They were developing it. And when we explained to them what the differences were and why, because the why is very important, they made the choice without regard to cost.
Right.
And so there you really have a case where an owner has put their money where their mouth is. They chose based on GWP, with other physical properties and other essentials being fundamentally equal. And it's really the case in our industry that the materials that we compete with, we are all relatively equal. There aren't physical properties that separate us. But the GWP numbers absolutely do.
Well, and let's talk a little bit about those numbers. The embodied carbon in construction calculator, the EC3 tool, great tool, is used by design professionals for lead projects. Could you discuss how the EC3 tool is used for fireproofing to assess embodied carbon?
Yeah, I can do that. To one of Rick's earlier points about the company we work for sort of being willing to step up to the plate. So when we reached out to EC3 about a year ago, and we said we would like to see applied fireproofing being added to one of your spec sections so that an architect or a specifier is able to see the embodied carbon of the three suppliers in this field. And they said, well, we would like to do it, but we don't have the resources right now. We would need somebody to sponsor it. And we knew getting into it that sponsoring it would really get us nothing in terms of we wouldn't get we wouldn't be the first one off the lot or get a big banner or anything like that. We would just help them upload or create the program. We've been very transparent about this. We didn't play favorites. We just sourced all of the publicly available EPDs for fireproofing and walked the folks at EC3 through the different types of fireproofing, and we were able to set it up so now an architect or a specifier can go into the 0781 spec section, select applied fireproofing, and all of the information for all three manufacturers is there, and that allows them to compare or apples to apples, and from there make a decision. We've been very fortunate, I think, in that there are only three manufacturers. And so in order to develop the product category rule, everybody had to come on board. All of the manufacturers had to work because we needed 80% of the market to develop the PCR. Once the PCR was developed, we were able to develop our LCA. And I'm going to keep going with the acronym salad, and from there, get the EPDs. And so all of the EPDs are developed off the same PCR. So you're able to compare with the unit of measure for all of the products in this space is the same. And so from there, it's very straightforward to be able to compare your product against somebody else's product against the next one, even if you may have differing numbers of or different quantities of each product on the job. It's very easy to compare them. They've been all of the folks there at Building Transparency have been great to work with.
That must have been a wonderful season putting all that together and really collaborating like that. I think that would have been so rewarding.
Oh yeah, it was, and the fireproofing industry. There's only three of us, so we all know each other. We see each other at all the ASTM meetings and the various trade shows and stuff. And to their credit, all of the manufacturers have been pretty good about at least taking the industry and moving it, moving it forward. Yeah, and it was good. But aside from that, working with the building transparency folks, just to have the idea and then to see it 3 months later be live and allow architects to be able to make an informed decision on the GWP of fireproofing was great.
I imagine we'll have to do a small case study on that sometime in the future, just getting that story down.
How do you get 3 different manufacturers to agree to do something?
Right.
And then they all do it successfully.
That's what I'm saying. That's
to a great extent, we're competitors every day. And yet we all came together to make this work. And John, I think it's fair to say, led the charge. And at the beginning, we didn't know the outcome.
Right. Risky.
It was a little bit risky.
Yeah. That's but the reward is great, right? And I think it's a model example of what people could be doing, right, to advance the mission of sustainability across the board, across industries. So cool. So the aggregate used in cementitious fireproofing can affect its global warming potential and therefore its performance for LEED projects. Can you discuss the different aggregates used in the products in the industry today?
Sure, I'm happy to, because it's not complicated. And if it was, I would let John describe it, but I can handle this one since he gave us the word salad. Fundamentally, cementitious fireproofing, as I said earlier, is either based with gypsum, or it's fundamentally cement based. And after you get past that, there is a little bit of trade secret involved, but we use a synthetic polymer to make the material light, and our 2 competitors use vermiculite to make their product a little bit lighter. And vermiculite also has some fire resistive capabilities. So if you think about a bag of gypsum, which the product would be, or a bag of cement, you really don't want to spray a bag that's purely gypsum. And so there are those aggregates that make it lighter. In our case, it is synthetic, and vermiculite is the other. And it really turns out that it's the big difference. I mean, if we look at the products and we know that they're so very similar in what they are, it's really the aggregate that plays a big role in the GWP.
That's enormous, I think, for understanding how people can specify it correctly and how it can be utilized. When we're looking at how GWP is different between the various industry products, how does that impact design professionals?
Well, I think it's going to impact them first and foremost if they care. So they have to actually care about the GWP of the product that they're specifying. And it's certainly possible to have values that are known and specified just like any other value that we have in physical properties for fireproofing. And I think that that's really where it starts. We've talked about fireproofing, the applied fireproofing section, and that we're not on every project. Certainly in concrete buildings, we're not a factor at all. But for the buildings that we are involved in, it tends to be that there is a lot of material. There was a study done in Massachusetts that showed that after concrete and steel, Division 7, where applied fireproofing resides, was the next biggest contributor to embodied carbon for that project. And when you actually really look at the products in Division 7, there's probably nothing else that's 1 million pounds on their project like the applied fireproofing was. So in terms of specifying the materials, I think first and foremost, it has to matter. And if it matters, there's a physical property that's easily listed in a specification.
Well, that's helpful. And it has me thinking a little bit about resilient design and how that plays a role in LEED v4 and the upcoming LEED v5 rating systems. How can cementitious fireproofing help design professionals meet their resilient design strategies and mitigate the effects of climate change?
You only want to have, when you fireproof something, or whether you fireproof something or whatever you do, you only want to have to do it once. You don't want to have to repair continuously. You don't want to have to replace it. Cementitious fireproofing like ours and cementitious fireproofing that's sold by our competitors, generally speaking, you want it to remain in place for the lifespan of the building. You don't want to have to repair it. You have to repair it. You're just spending more money, but you're obviously global warming potential. If you have to double it, it's double. So when you talk about 75% of the buildings that will be around in 2050 or whatever that number is have been built already today, you want to make sure that your building is going to last for hundreds of years. Cementitious fireproofing, unlike say a fiber-based product, has a reputation for remaining in place for the lifespan of the building. We regularly get pictures and test reports from contractors who've got fireproofing or our fireproofing that's been in place for 35, 40, 50 years that looks exactly like it did when it was applied, and the physical properties remain the same. It's still well bonded to the steel. The thickness is still there. It's not flaking off, and that's what you want. You want your product to remain in place, to be resilient.
Laura, again in Chicago, because it's where I live, on the front page of the Chicago Tribune, a couple weeks ago, they showed the old Sears headquarters, which was one of the first projects I ever worked on myself as a salesperson in the early 90s, was being torn down. It was a massive complex. It was being torn down to make way for a data center, multiple data centers actually. And the picture's there, and it's of course got a wrecking ball, and the building is, as you would expect in a still picture. But my eyes just went directly to the fireproofing. And I think over the course of time, maybe even my children, when they walk into a building, may notice fireproofing. But there, right there on the front page, you could see clear enough that there was our material that was installed in 1991, I think it was. All those years later, it looked as intact as it would have when it was first applied.
That's got to be incredible. I talk a lot about being a trusted advisor between, how manufacturer reps and people that work in manufacturing have to be strategic partners with design professionals in being able to convey something, not just to sell it, but because it needs to be integral. And so that has to be something that in that moment where you can see that product from decades ago and it's actually holding up to what you said it would do and what performance said it would do. I mean, like, what an excellent moment, I think. Those moments where you're like, man, it really is real. Seeing it in the building like that, it would take my breath away.
I actually don't think John will, go down the Chicago River Cruise with me, because as we go down the Chicago Architectural River Cruise, and he's probably just sick of me pointing out the buildings that we worked on over the course of time, starting in 1990, that are all along the river, that we were successful with installing our materials.
Well, it's the same, when I'm driving into Boston and I say, "You see that over there?" And my son will say, "Yeah, I know, Dad, you built it by yourself at the weekend." Yeah, you did it. So.
Yeah, but it will matter to them too,
Absolutely,
yeah. That's very awesome. So I think we've established that sustainable manufacturing is really important, right? It's important to help fight the effects of climate change and is part of the LEED rating system. Can you discuss the cementitious fireproofing manufacturing process and how it uses sustainable energy, such as hydropower?
John, why don't you take that?
As I mentioned earlier on, so where we make our material happens to be in a place that has been very focused on hydropower. And this was a mandate by the regional government that there was going to be several towns in the area that were going to get all of the municipal energy from hydro. And dumb luck would have it, we were based in one of those towns. And so now when you compare, when you look at the EPDs of ourselves and our competitors, and you look at the manufacturing cost in terms of embodied carbon for our products and theirs, you see that there's a huge difference between the two. And, some of our competitor plants are located in areas where there's a heavy reliance upon fossil fuels. And we just happen to be in a place where our manufacturing plants are located in several areas around the country where there is a strong focus on weaning the energy systems away from fossil fuels. And because of that, mainly because it's hydro on one of the plants and wind and solar and some hydro and a small bit of natural gas in the other, the embodied carbon of our products really has a huge jump start at the start, because of our use of renewable energy. We actually talked with, several years ago, I talked with one of the companies, the EPC companies that were involved in the electrification or the, I don't know if there's a word, but hydroification of their electric system in that town. And he said, well, yeah, we were thinking about this and we might have done the town next door, but luckily for us, they chose the town that they are located in, and here we are.
I'm so glad to be talking to you today, John.
Yes, it brought us together, so I'm happy about that. But yeah, that was kind of the story, and in terms of power, why we have so when we look at it and you break it down into sort of sourcing of raw materials and manufacturing and transport and whatnot, the big benefits that we have, or where our products seem to do best compared against our competition, is our electric sources are much cleaner, and our raw material sources are much closer to our plants. In particular, some of them are. Our process tends to be more of a blending process as opposed to there is a part of the vermiculite production process that is very energy intensive, and we don't have that. We haven't sold a vermiculite product for almost 50 years.
And when John talked earlier about raw materials and sourcing them very close by, for both of our plants, one which is in Ontario and the other in Southern California, both plants source the vast majority of their material from within 200 miles. So we don't have much transportation cost. As John said, we're a blending operation. We take products and mix them together, literally blending them, which is not very power intensive either. And you compare that to the process of getting vermiculite over from South Africa. In most cases, there's some US vermiculite, not very much. You get that vermiculite over here, and then you have to, not only, get it off the boat that it came on, but you have to expand it. And expanding vermiculite is like popping popcorn. And it's very heat intensive. And, you compare the energy that's used in that operation to the mixing operation that we have, and that also gets us to the point where, for the majority of our products, our global warming potential is 60% less than the competitors in the field. And 60% less is a measurable difference. It's a lot. So again, for those projects that matter, then physical properties have to be listed in specifications.
So the hydropower is really a useful aspect. And then also the requirement of energy load to blend it creates it kind of creates a perfect storm for reduction of a GWP. And the locale, right, is also an incredible advantage. So when design professionals are looking and working on lead projects and they want to specify products that have few or no hazards, do the materials you're discussing kind of support that? Can you describe how some HPDs and declare labels help design professionals specify healthy products?
Yeah, go ahead, John.
But this is one of the things that was sort of the for me personally is something that has been a great story, or is a good story for me. So it was about 2013 or so, and just when declare labels were starting, or transparency labels were starting to become a thing, and we had it was University of Chicago, I think, Rick, project, and the Brightworks, I think, were the consultant on it, and Brightworks came to us and said, we want to see, we're looking for more transparency on your product, or there's no way we're going to use it. And and they said, we were looking at this very short list of products that you can't have in your final formulation, because that, the declare labels have just gotten so much bigger, right? Much longer. And so we looked through it and said, well, yeah, we definitely know asbestos, and there's no lead, and there's no chromium. And one of them, we said, well, we might do. Right. So we went back to the supplier and we said, is there any of this in your raw material? And he said, yes, there is. So we went back up through the consultant and through back to the owner, and they said, there's no way we're going to have this. And so we went back down to our supplier and said, if you don't change the formulation of the raw material you're providing for us, we're not going to use you anymore. Right?
Oh my.
And they did. And so they removed the offending raw material. We were able to go back then and went through ILFI and got ourselves a declare label and back to Brightworks and then back to the owner, and we were there. And so, you know, it's a thing, but like, I think that goes to show the power that the building owner does have in terms, or the architect, in terms of driving this whole conversation forward, that they force the manufacturer to make a raw material change that would make the product less harmful to the inhabitants of the building. And that's something that I think, you know, that to me, it just speaks to the power that the owners do have in terms of driving this forward, and the architects. If specifications included a maximum GWP for all building material sections, and they said, we're not going to use it unless you do that, industry would change within 5 years. Absolutely. It's just that we're at that tipping point, and I feel we're creeping over it because we have seen a couple of specifications from big architectural firms that list global warming potential as a parameter, and it's folded into the form and function sort of section now, where it's like any other physical attribute, and that's great. That I think, you know, I'm very proud of the fact that we were on that University of Chicago project, that we were able to drive it, and it became a thing for us. Like, several building owners like Hines and stuff have sort of drawn a line in the sand and say, none of these. And the industry has followed suit, which has been great. I think we're a poster child industry for.
It's nice. It is nice to have the architectural community specifying it. But we've even seen general contractors without architectural specifications listing GWP as a factor in buyout. You know, Turner comes to mind. You know, some recent projects where we've had to answer questions as to GWP. You know, the architectural community needs to specify it, but the general contracting community has to also embrace it. And we have seen the big names in North American and global construction that have started to adopt it and have started to ask our contracting customers for us to provide them with the information.
What a moment, you know. It's such an inspiring story to listen to. I think there's a lot to commend here. I think that demand, you're right, John. I think that's the way to do it. But I think there was a buildup before that where you had to get to that point where you could make the demand, right? Things like infrastructure have to be in place. You're talking about, you know, the hydropower scenario, or if we continue to build great energy sources, it can help contribute to the overall success, I think, across the board. It's a great moment to observe. Now, when we're looking at the implications here of reducing the concrete thickness to the minimum thickness required, are we able to achieve structural integrity still? And utilizing a spray fire resistant material product, are we still able to achieve those required fire ratings?
It's an interesting question, and one that we asked the consultant to address. It'd been a bit ago. We had a particularly thoughtful sales rep that kept saying, you know, I think we could really be a lot more sustainable if we could just convince the architectural community that they didn't have to have these big, thick concrete slabs. And if they could go to a thinner slab and protect their decks with fireproofing, not only does it make the fireproofing market bigger, but it also would lead to more sustainable construction. And I was in charge of the business at the time and just ignored everything he was saying because I didn't think that we could actually impact the way structures were being built. I just didn't think it was possible. So in one ear, out the other for me. And as we got, you know, further along, call it 5 years, he really was a good thinker. The idea came back up again, and as I've done before with any idea, I went to Mark Walsh at Perkins and Will and posed the question to him: if we were able to show a significant savings in carbon reduction for buildings, structural steel buildings with metal deck and concrete poured, if we were able to show that, would the industry accept it? Or are there reasons for the slab thickness being what it is that, you know, just kind of dictate that that's what the slab has to be. And I was shocked at the answer. I was shocked to hear that most often the slab thickness is directly related to having it be fire rated, and that it had to be a certain thickness to not have to apply fireproofing on the deck. Of course, they had to protect the steel frame, but they wanted to not have to fireproof the deck. And I have to say, even though I'm biased, fireproofing a floor deck is about the fastest, easiest, most economical thing you can do. Mark went on to say that there were some vibration concerns that we would have to address. And so, okay, I understand that. And that there could be user comfort, the comfort of the person in the building, maybe building swaying, he brought up. And so we thought about all that too. But ultimately, we see across North America a very regional approach. In Chicago, we very rarely fireproof decks. We almost always achieve fire ratings with concrete. But in the Seattle market, and you think with the earthquake potential, maybe they have stronger buildings, I don't know. But in the Seattle market, we almost always fireproof the deck. And same goes for San Francisco. It's very, very common to do that. And so they're building tall buildings and there's occupants in them. And it seems that it really is driven by the fire rating.
Right.
And once the study comes out, I think that it's going to be a real eye-opener because the savings are significant. When you thin your concrete slabs, very intensive material, concrete, and you replace it with fireproofing, very little carbon footprint, you end up with a much more sustainable building.
Well beyond the noise. Like, we were kind of surprised. We did our own calculations and we were a bit off, but not by a lot. But we were continuously looking for a mistake, like a decimal point in the wrong place, because we couldn't believe that the difference was so big. And when we did go to the third party consultant, it wasn't just a case of a one-off building. We talked about different types of concrete, whether it was in a seismic or not area, whether it was restrained and unrestrained, the coast it was on, we put a lot into it. And the results have been sort of really eye-opening in terms of, if you're looking for a silver bullet to reduce the embodied carbon of your building.
It's so simple. It's not a new technology.
Yeah.
And decks are fireproofed across the country, but it's not a common practice. So make it a common practice. And of course, there's going to be mechanical equipment that's going to dictate a thicker floor slab in certain areas. That's fine. But for your general floor areas, you can thin your slab to 2.5 inches of normal weight concrete, much more carbon friendly than lightweight. And take that thickness from 4.5 inches of normal weight down to 2.5, or take 3.25 inches of lightweight down to 2.5, spray your deck and enjoy the savings. We haven't gotten into the economics of it, but Eric was saying, everything about your building becomes lighter and therefore more sustainable. And if I could say, they're lightable and more sustainable construction and making a world a better place is really true. And I think that this falls right in line with what we want to do for the built environment. That slab thickness difference and just the nature of normal weight versus lightweight concrete being more sustainable, and that overall volume of concrete that's going to be reduced from the building. And that's really what it gets down to, is that simply you're using a smaller foundation. The work underground all becomes lighter. The wide flange steel members in the tube columns, or the wide flange columns, they can become lighter because they're not supporting the same load that they had when they had so much more concrete. And I'm far from a structural engineer. I'm far from it. But the conversations have been so casual about, of course, these are the consequences, that if I can understand it, I would think that the architectural community should understand it. And I would think that the structural engineering community should understand how much more sustainable their construction can be simply by using applied fireproofing on the underside of floor decks.
Yeah. And it makes me kind of inquire about the maintenance and durability of the products. I know you've mentioned that you've seen something that was in decades ago and it's still intact. What are the maintenance requirements? Are there any for cementitious fireproofing?
There really aren't. There's code requirements to inspect it, but generally speaking, both our material and our competitors' cementitious materials are all built for the long term, and there's not that much that differentiates between the two of us in terms of the physical properties of our product. They're very, very similar. I think that there are things that the architectural specifying community can do to even further reduce their embodied carbon of their applied fireproofing. We see that cement-based materials, which are more expensive and they are worse in GWP, are sometimes needlessly specified. We do like their specifications. The material's a lot more expensive. The contracts for our customers are a lot bigger when cement-based material is used, but it's oftentimes specified needlessly. We have high-performing gypsum-based materials that, unless you're in a swimming pool, or being subjected to rain and snow and vehicle damage, chances are what is specified to be done with a cement-based product can be done with a high-performing gypsum-based product. The physical properties get very close between the two categories. So by evaluating even the applied fireproofing that you have in the building and whether or not, the durability concerns actually are as intense as they might think they are, looking at a set of drawings, you can reduce the GWP by 50% there too.
So overall, it helps with resilient design strategies for LEED.
Oh, absolutely. And, I think that difference between Portland cement and gypsum-based materials is significant. And as you mentioned, especially with LEED 5 coming up, it's going to be a big winner. But we do recognize that cement-based materials are important in construction. We can't just use gypsum everywhere. I think you can make an argument for using the gypsum-based cementitious products often, but you're going to end up with cement. And with John's encouragement and his looking out into the future, we spent a lot of money over the course of the last year and a half taking our cement-based materials and switching out the cement, the main part of the product, from ordinary Portland cement to Portland limestone cement. And I fundamentally just exhausted my knowledge of the difference between ordinary Portland cement and Portland limestone cement. But John encouraged us and said that it actually was going to lead to a much more sustainably focused cement-based product, and one that actually truly made a measurable difference when comparing even our previous product formulation to this one. And so we took the risk because like any test, when you change the material, there's no going back. But we took the risk, and it turned out that we had great results. And so now our cement-based products are even more LEED or carbon friendly.
So when we're looking at materials reuse and salvaging materials from demolished buildings, as an important strategy for LEED, can cementitious fireproofing products be recycled or repurposed?
Not really, but I think what we've seen, especially in renovation projects, really common in hospitals, it's a big segment for us. What you see is that the material that was installed originally is as good as it was on the first day. And so you don't have as much rework as you might have if you had inferior products. So the cementitious category staying in place. We wish that it could be reused, but it can't. But the fact that in renovations you are very rarely going to have to refireproof probably is its greatest attribute.
So with low emitting materials being an important part of LEED, are there any VOC emissions that we could consider when looking at cementitious fireproofing products?
No, that's a really simple answer. So products contain there's no VOC content, and the VOC emissions are acceptable per the California, the SQAMID. I can't remember what the acronym stands for now, but see the California Department of Public Health, the standard 1350, which is what Green Guard tests. So products are acceptable for use in offices and classrooms, which are the two standards that they talk about. So we have done those testing. We have done those tests for all of the products that we have, and we're acceptable for use. VOC and emissions is not something that is of concern to us. It is. I mean, if it came back that we did have a VOC emission problem, we would make a modification.
No, understandable. So there's not only is the future bright, but so is your history. So when we're looking at the future developments, what do you see on the horizon? Is there anything coming that you haven't already achieved that you could achieve even further?
Our organization is spending significant amount of money in all measures of becoming more sustainable across their portfolio, from glass to building envelope materials to the products we manufacture to gypboard to ceiling tile. It's really it's a major focus, and within that focus there are places where the size and scope of the organization that we work for can help our materials become more sustainably focused. I mean, John's mission for the last, 3, 4, 5 years to figure out how we can use recycled gypsum board in our commonly used products. And if it's not as easy as one might think. And if we do, it's game changing.
Do you think it would inspire industry-wide change as well?
Potentially, but in terms of the difficulty in which we're finding it is, and the difficulty hasn't caused us to give up. The extent that it is difficult to use recycled gypsum in the materials that we manufacture, I don't think that our competitors will have the same stomach towards figuring it out. So it very much could become another differentiator.
What do you see for the future of sustainability, John?
Oh, I think we have we've gone beyond the tipping point with respect to from a building materials supplier. We've gone beyond it. I know that not just from talking to people internal to our company, but across the board in all manufacturers, that sustainability is now a gate that every new product from any reputable manufacturer has to pass through. And so thankfully, I think we're going to see a movement away from the use of harmful materials, far more recycled or reused materials, less virgin sources of material, and definitely a huge move towards electrification of the power grid that's used to make these products. I think if we were to look now at the GWP or the embodied carbon of products that are made now, and if we were to go forward 10 years and see what they'll be in 10 years' time, I think we're talking order of magnitude reduction in terms of the GWP of products. The ramifications for not making these changes are becoming pretty apparent, and Rick had mentioned Perkins and Will and several others, and the one of the common sort of traits is that the ability of business to carry on business as usual is going to be severely impacted by climate change. We need to the building materials industry, I think, is making some pretty big steps there, which is good to see.
Yeah, Laura, I think it's entirely personal. And I think we look at the built environment and we say the built environment's a big part of the problem with global warming. And I guess as companies, we're part of that, but as people, we are part of the companies. And it's folks with drive like John's that, make a difference and make a measurable difference. We know the ramifications. I had beautiful sunrises in Chicago last year over Lake Michigan as the fires were burning in Eastern Canada, sending smoke down here that made it so that the air conditionings were running full time, even when it was 70 degrees. I mean, that's personal to me. And having family that lives down on the coast and knowing how it just seems like the storms have such greater strength now, and there's so much more peril in Florida and up the coast that, well, I think the people are going to start noticing, and it's going to be personal for a lot of folks. And so we have that obligation to make a difference. And make a measurable difference. I often give a presentation and I start out by asking the audience to vote as to what kind of person they are. Are they the kind of person that recycles an aluminum can? I mean, it's just an aluminum can. Why are we so worried about an aluminum can? It's because over time, we've begun to develop the belief that our recycling a single aluminum can matters, or a plastic bottle. And kudos to all of those in the industry that reuse plastic bottles and actually really publicizing it. And, the built environment, we're lucky. We don't have to convince people that it's an issue, generally speaking. We don't have to convince them that it's something that we are responsible for to a great extent. We do have to convince them, though, that there is something that they can do about it, and
Right.
that it does need to be more than just a statement on a website. It has to be more than having a sustainability officer. It has to take it to the point where there are properties that you can specify, and that the building materials that you're using as the architect, as the builder, as the owner, they all matter. And it's not difficult to make good choices.
Yeah, I think that's a great takeaway for me too, is that in your previous podcast, Yukari, she talked about sometimes there's difficulty in finding this information. But I think for fireproofing and for lots of building materials now, it's sort of the choice is relatively easy to make because there's so much information out there. And yeah, I think that, to echo Rick's point, that's where we're at.
I think there's more and more support too. You have the components of the industry, but then you have kind of a groundswell of like, let's get it done. Let's help manufacturers especially understand how to accomplish it now that they're deciding to take the risk to join the movement of it. And even with the new LEED V5 and just making sure that there's a common language around it so that everybody's talking about the same thing. I think they're just great strides, in this moment in time is really one worth kind of taking stock of how far we've come and then turning and saying, okay, where can we go from here? So I think your both points are very strong. We're going to close here with our last question, gentlemen. The primary goal of this podcast is to build a catalog of wisdom for the industries that we serve. What is one piece of industry wisdom you would like to share with our audience in closing?
I'll take the first stab, John. In closing, our industry that we are in is manufacturers of applied fireproofing is very small. And ultimately, the cost between the two different manufacturers' materials is fundamentally the same. Of course, there can be small differences. A percentage point here, a percentage point there. And I'm not going to dismiss the fact that dollars do matter in construction. But if we're going to look at sustainability as something that matters, then it should matter. And I'm not saying that it's without regard to price. Suffolk Construction has a good statement on their website that is regarding sustainability, where they talk about value, because clearly economics have to come into play. You can't just choose sustainability without regard to cost. But in our industry, as small as it is, and with share split fundamentally 50-50 between the two bigger manufacturers, we know costs are equal. We just know that. I certainly know it after 30 years. So if costs are equal and you have a chance to make a more sustainable choice, well, why wouldn't you? And or at least why wouldn't you ask, as an architect, a builder, if there was a way to have the more sustainable product used in an economical fashion?
That's a great point, John.
What he said. He had prepared that. He must have prepared. He didn't come up with that.
I gave it to him ahead of time.
I never read anything ahead of time. Just ask anybody I work with.
You got an earbud or something in there?
No.
The answers.
No. It was from the heart, what I feel after 35 years in this business as a contractor and a manufacturer. Do what's right. And that's the thing.
Yeah, I think a pearl of wisdom, probably, it would be rare enough that I would offer up a pearl of wisdom. But I would say that if you are an architect or a building owner looking at applied fireproofing, it is relatively easy now to make a choice that will reduce the embodied carbon of your building. That's about it.
Hmm.
I'm a man of few words, you see, Laura.
No, I understand it. I appreciate it. I can't thank you both enough for being here today. We look forward to talking to you again in the future and commend you for all the work that you've done.
Thank you. It's been
Thanks
great.
very much. It's been a lot of fun talking about it.
Yeah, that's
Absolutely.
all right. Super. Thank you, everybody.
Thank you for listening to the Spec Shaman podcast. If you enjoyed today's episode, please subscribe to our show and leave us a review. The Spec Shaman podcast is produced by Laura Elliott and Brad Blank. A huge thank you to our guests who made this show possible. Building product manufacturers who want to increase their specification opportunities, please visit specshaman.com or ronblank.com. Thanks all for this episode, folks. See you next time.